The music of the cosmos. Sound. It's the language of the universe, a universal code that transcends barriers and speaks to the very core of our being. A symphony of vibrations that paint the tapestry of our existence. Each note, each frequency, is a brushstroke in the grand masterpiece of life. From the whisper of the wind to the roar of a rocket launch, sound is ever present, shaping our experiences and memories. Sound informs us, moves us, and connects us. It has the power to evoke emotions, to bring people together, and to create moments that linger in our hearts. It's a fundamental aspect of our reality, and understanding its intricacies opens a door to a world of wonder. The study of sound is not just a scientific endeavor. It's a journey into the essence of what it means to be human. In the realm of high-end audio engineering, we delve into the very essence of sound, exploring its depths and uncovering its secrets, seeking to capture its nuances and reproduce them with breathtaking fidelity. This pursuit is both an art and a science, requiring a delicate balance of technical expertise and creative intuition. It's a quest to recreate the magic of a live performance, to capture the energy and emotion of the moment, and to deliver it to the listener with unparalleled clarity, to transport the listener to the heart of the music. When done right, it feels as if the musicians are right there with you, playing just for you. This pursuit of sonic perfection takes us on a journey through the fascinating world of physics, where we explore the principles that govern sound and its behavior, where we unravel the secrets of sound waves, frequencies, and the delicate dance between acoustics and perception. We learn how different environments and materials can shape and alter the sound we hear. Our exploration begins with the fundamental nature of sound itself. We dive into the physics of sound waves, understanding how they travel, interact, and ultimately reach our ears. This knowledge is the foundation upon which we build our quest for perfect sound. Sound's stellar journey. Sound is an incredible phenomenon that we often take for granted, yet it plays a vital role in our daily lives. From the music we enjoy to the conversations we have, sound is all around us, constantly shaping our experiences. The speed at which sound travels depends on the medium through which it's passing. This means that sound can behave quite differently depending on whether it's moving through air, water, or even solid materials like steel. In the air, at room temperature, sound zips along at a brisk pace of about 767 miles per hour. This speed can vary slightly with changes in temperature and humidity, but it's generally consistent enough for us to rely on. That might seem fast, but it's a snail's pace compared to the speed of light, which clocks in at a staggering 186,282 miles per second. Light's incredible speed is why we can see things almost instantaneously, while sound takes a bit longer to reach our ears. This difference in speed is why we see a lightning bolt before we hear the clap of thunder. When a storm is raging, the lightning and thunder occur at the same moment, but our senses perceive them at different times. Both events happen simultaneously, but light, traveling much faster, reaches us first. This phenomenon is a fascinating demonstration of the varying speeds at which different types of waves travel. The sound of the thunder, traveling at a more leisurely pace, arrives a few seconds later, depending on our distance from the lightning strike. The further away we are, the longer the delay between seeing the lightning and hearing the thunder. The medium through which sound travels plays a crucial role in determining its speed. For instance, sound moves much faster through water than it does through air, and even faster through solid materials like steel. In denser materials, like water or steel, sound travels much faster than it does through air. This is because the molecules in these materials are more closely packed together, allowing them to transmit sound waves more efficiently and quickly. This is because the molecules in denser materials are packed more tightly together, allowing them to transmit sound waves more efficiently. The closer proximity of the molecules means that the vibrations that constitute sound can pass from one molecule to the next with greater ease and speed. This is why, for example, if you were to tap on a metal pipe, the sound would travel through it much faster than it would through the air around it. Underwater, sound travels at about 4 times the speed it does in air. This is why marine animals, like dolphins and whales, rely heavily on sound for communication and navigation. Their ability to send and receive sound waves quickly and over long distances is crucial for their survival in the vast ocean. Understanding the journey of sound through various mediums not only enhances our appreciation of this natural phenomenon, but also has practical applications. From designing better acoustics in concert halls to improving underwater communication systems, the study of sound's behavior is a field rich with possibilities. Sound's stellar journey through different mediums is a testament to the complexity and beauty of the natural world. By exploring how sound travels, we gain insights into the fundamental principles that govern our universe, and we can harness this knowledge to innovate and improve our technology and daily lives. The symphony of frequencies. Just as light is composed of a spectrum of colors, each blending seamlessly into the next to create the vibrant world we see around us, sound is made up of a wide range of frequencies, each contributing to the rich tapestry of auditory experiences we encounter daily. These frequencies, measured in hertz, determine the pitch of a sound. The higher the frequency, the higher the pitch, and vice versa. Low frequencies produce deep bass tones, the kind that you can feel vibrating through your body, adding depth and power to music and sound effects. While high frequencies create the shimmering highs of cymbals and piccolos, adding brightness and clarity to the sound. The human ear, a marvel of biological engineering, is sensitive to a remarkable range of frequencies, allowing us to perceive everything from the lowest rumbles to the highest pitches. From the low rumble of a distant earthquake at around 20 hertz, a sound so deep it is almost felt rather than heard, to the piercing shriek of a bat at 20,000 hertz or 20 kilohertz, a frequency so high it is beyond the range of human hearing. This range, known as the audible spectrum, encompasses the vast majority of sounds we encounter in our daily lives, from the hum of a refrigerator to the chirping of birds. In the world of high-end audio, capturing and reproducing this entire frequency range with accuracy is paramount. High-fidelity equipment strives to deliver sound that is as close to the original recording as possible. Every note played by an instrument, whether it's the deep resonance of a cello or the bright twang of a guitar string, every inflection in a singer's voice, from the softest whisper to the most powerful belt, vibrates at a specific frequency or combination of frequencies. To faithfully recreate the original sound, audio equipment must be capable of handling this entire spectrum without introducing distortions or limitations. This requires precision engineering and high-quality components. The quest for perfect sound reproduction has led to the development of various audio formats and technologies, from vinyl records to digital streaming. Each format has its own strengths and weaknesses, but the goal remains the same: to bring the listener as close as possible to the original performance. Whether in a concert hall, a recording studio, or through a pair of headphones, the symphony of frequencies is a testament to the power and beauty of sound. It enriches our lives, evokes emotions, and connects us to the world and each other in profound ways. The symphony of frequencies is all around us, waiting to be heard and appreciated. Our sonic senses. The human ear is a remarkable organ, capable of detecting minute pressure variations in the air and translating them into the sounds we perceive. When sound waves enter the ear canal, they strike the eardrum, causing it to vibrate. These vibrations are then transmitted through a chain of tiny bones in the middle ear, the malleus, incus, and stapes, to the fluid-filled cochlea in the inner ear. Inside the cochlea, thousands of tiny hair cells dance in response to the vibrations, converting them into electrical signals that are sent to the brain via the auditory nerve. The brain then interprets these signals, allowing us to perceive the pitch, loudness, and timbre of a sound. The clarity of sound. One crucial aspect of high-end audio engineering is minimizing noise and distortion. Noise in this context refers to any unwanted sound that interferes with the desired audio signal. This could include everything from the hiss of an amplifier to electromagnetic interference from nearby electronic devices. Distortion, on the other hand, occurs when the audio signal is altered in a way that changes its original characteristics. This can happen at various stages of the audio chain, from the microphone capturing the sound to the speakers reproducing it. Common types of distortion include harmonic distortion, which adds unwanted harmonics to the signal, and intermodulation distortion, which creates spurious frequencies not present in the original sound. Building a sonic sanctuary. While having top-of-the-line audio equipment is essential for a high-fidelity listening experience, the acoustics of the listening room itself play an equally crucial role. Just as the shape and materials of a concert hall influence the sound of an orchestra, the characteristics of a listening room can dramatically impact how music is perceived. When sound waves encounter surfaces within a room, they are reflected, absorbed, or diffused. Hard, reflective surfaces, such as bare walls and windows, tend to reflect sound waves, creating echoes and reverberations that can muddy the sound. Soft, absorbent materials like carpets, curtains, and acoustic panels help to absorb sound waves, reducing reflections and creating a more controlled listening environment. The goal of room acoustic treatment is to achieve a balance between reflection, absorption, and diffusion, creating a listening space that is neither too live nor too dead.